I'm reading my morning newspaper. I'm reading it through this window, which is 1 column wide and a few lines high. You may feel that this is rather an eccentric and ineffective way of reading a newspaper, and of course you'd be quite right, because all the time I'm looking through this window, I would be asking questions such as, how many articles are there in this column? Are there any interesting photographs? What other articles are there? Where's the crossword? And in general, where am I in this information space? Now, this is a silly way to read a newspaper, but it's very similar to the way in which we use a conventional visual display unit to look at one item of information in a large information space, whose periphery we could probably only just see if it was printed on the same scale as a newspaper. Now, this technique of windowing has many disadvantages. Perhaps the principal disadvantage is the absence of any context. I do not have a bird's eye view of the information to help me to decide where to focus my attention. Windowing on a particular item masks all the remaining items. There is a way of overcoming this windowing problem with its associated effect of masking. And it can be demonstrated very simply by taking our newspaper article and by adjusting the view that we have of the article. In this way I can focus in some detail in the central region, but at the same time be aware in the peripheral regions of salient features such as headings and photographs and cartoons. In other words, I can retain a bird's eye view of the entire article. Let's apply this idea to my in-tray, an information space which is quite varied and often full of surprises. Here's a simple example in which I've used colour to indicate some property of an item. Red indicates an urgent item. The yellow one is from my secretary, and telexes are always orange. By properly designing my view of this in-tray, I can focus on one item, but at the same time be aware of the salient features of other items. The colour of each item, for example, is clearly visible in the outer regions. Thus, while perusing the contents of my in-tray, I always retain a bird's eye view of the entire contents. Now, when an item moves into the outer region, of course, it is compressed horizontally, and it is therefore very difficult to read the text. But of course, one does not want to read the text in this outer region. One wants to be aware of attributes such as colour. Indeed, each item of information has two representations. One, which is appropriate to the central region of the display and which we can read, that's a high resolution image, and another low resolution image which is appropriate to the outer regions and where we only need to recognize perhaps a colour and a letter. So if we take this representation and thread it into this structure, then we have the representations appropriate to the outer regions. If we then, in this central region, replace that image by an image appropriate to that central region, then we have the display that we're looking for. We can read that single item in the central region, but we are still aware of other items that are available in my in-tray. This manner of representing information is called the bifocal display because it has got two regions having different resolutions. The central region with high resolution and the outer regions with low resolution. And we can focus on a particular item of interest while still retaining a bird's eye view of the entire in-tray. Now, this is a very simple example using 5 items simply to illustrate a concept. Perhaps a more representative in-tray might be the one that we see here, with a wide variety of items and a large number of them, a little circle there indicating a voiced message, various letters that I'm sending out, documents that I'm preparing. There's another voiced message at the bottom. A number of items that we are looking at through a window at the moment. Here is a bifocal display of the same in-tray as it would appear on the desk of the user. Normally, the user would view the bifocal display through a touch screen, so that, on noticing an item of interest in an outer region, a finger can be used to scroll the in-tray horizontally until that item is in the central high data resolution area and can be examined in detail. The same mechanism allows browsing, which is a very valuable human activity, to be an instinctive action rather than something which has to be consciously planned. Future information systems must be designed as far as possible to be used by people having no knowledge of computers, and that includes the vast majority of people such as storekeepers, doctors, lawyers, and secretaries, for example. Also, very little training should be required. Ideally, the use of an information system should be instinctive. In our opinion, the bifocal display is compatible with these requirements.